Hi guys, so let's see the question number 1 of RMO KV 2025. So in this we have given a A1, A2, A8 are non-negative integers where none of them is equal to 1, right? And these conditions are given. A1, A2 is A3 plus A4 and so on. So first, as we include 0 also, right? Non-negative integers we are talking about. So if I assume any of them, one of them is 0, let's consider the case if when any one of them is 0. So if I say A1 is 0, then we get A3 plus A4 is 0, right? So sum of two non-negative number is 0 only when if both are 0. So A3 and A4 become 0. So similarly, from if I put A3, A4 here, I will get A5, A6 is 0. And similarly A7, A8 is 0 and A1, A2 is 0. So ultimately if I put any one of them is 0, in the same way we get all the numbers become 0, right? So the one solution we can see is all are 0. Now let's consider the case if AI is not equal to 0 as well as 1. So now if we consider this case when none of them is 0 or 1, then we can say AI is greater than equal to 2. Okay. So now for this, if you see the term A1, A2 is there and we have a A1 plus A2 also, and we are talking about the integer, so we can try to use SFFT, right? So we can try to use A1, A2 minus A1 minus A2 to factorize that. So for that, first time adding all these four, so we get summation of or A1, A2, A3, A4, A5, A6, A7, A8 is equal to summation of AI where I is 1 to 8, right? A1, A2, A3 up to A8. So now we shift these terms, this summation to the left hand side and combine them with the respective uh, what we can say variables like A1, A2 combined with A1, A2 and A3 plus A4 is combined with A3 into A4, right? Similarly we can say about A5, A6 minus A5 minus A6 and then we have a A7, A8 minus A7 minus A8 equal to 0. Now we will try to factorize that, as we know that if we have AI minus 1 into AJ minus 1, it is AI AJ minus AI minus AJ plus 1. So we do not have a 1 here, so we add 1 both side, means we add 1 in every bracket. So as we are adding 4 on a left side, we have to add 4 on a right hand side. So we get A1 minus 1 into A2 minus 1 plus A3 minus 1 into A4 minus 1 plus A5 minus 1 into A6 minus 1 and plus A7 minus 1 into A8 minus 1 is equal to 4. Now if we observe the left hand side, all the factors are greater than equal to 1. Because as all the terms are greater than equal to 2, A1, A2 all are greater than equal to, so can we see that all the term or all the products are greater than equal to 1, so the minimum sum of the left hand side is 4. So the minimum sum is 4 that can, and the right hand side is also 4, so that equality hold only when they are all are equal to 1, or we say A1, A2, A3, A8 all are equal to 2. So we have only two solutions, either all of them are 0 or all of them are 2. Hi guys, so let's see question number 2 of RMOKV 2025. So we have given ABC is a positive real number satisfying ABC is 1. Prove that this is less than equal to A square plus B square plus C square. So we have ABC is 1 and we have to prove this. So first thing that we can try, that can we make the denominator something good, like a cube plus 1 is there and we can put 1 is ABC, means if I pick let's say the first expression, if we pick the first expression, it is 2a square by a cube. If I put it 1 is ABC, what we will get, by taking a common, we can cancel out that a, we get 2a by a square plus bc, right? So we just try to simplify the expression. So we have this thing. Now can we further simplify that? So using ABC is 1, or what I can try, I can divide with the a, I will get a plus bc by a, right? If we divide with the a, we will get a plus bc by a. And if we see a plus bc by a is greater than equal to 2 root bc, right? A plus bc by a is greater than 2 root bc, because a will cancelled out, and from that I can say 2 by a plus bc by a is less than equal to 1 by root bc, or because 1 we can again write as a abc, or we can say root bc is 1 by a, right? Bc is 1 by a, so it becomes equal to root of a. So similarly I can say the second factor is less than equal to root b, and the third is less than equal to root c. So our expression, this one, is less than equal to root of a plus root of b and root of c. Now again we will try to see that can we achieve the equality also, right? So as we use a am gm on these two numbers, a and bc by a, so for equality we need these numbers should be equal, or we can say a square is equal to bc. Similarly for the second, this and this expression, we have b square is equal to ac and c square is equal to a. So from here I think we can say that a, b, c are 1, right? These are, because bc is 1 by a, so we get a is 1 and b is 1 and c is 1. Okay, so we can write root of a is root of a into abc, right? Because abc is 1, so we can multiply with the abc, so we get a square bc power 1 by 2. So it looks like a gm of a square, b and c, but we need b square and c square, and the power is also 1 by 2, we need at least 1 by 3. So I can multiply, or I can take a power 2 inside this bracket, so it will be a power 4 b square c square power 1 by 4. Now once we get this, I think now we can able to convert this gm into this form. Basically we have a 1 by 4, means we need a 4 terms, and in fact a power 4 can be written as a square into a square, right? So if we apply the am gm on this, now it is less than equal to 2a square plus b square plus c square by 4. Similarly the same thing we can do for a root b and root c, and finally when we add them we will get 4 times a4, 4 times b4, 4 times c4 by 4, which is a power 4 b power 4a square 4b square 4c square. So we get a square plus b square plus c square, right? So that is what we want to prove, that this is less than equal to a square plus b square plus c square. And also you can see the equality that we have in case of this am and gm is when a square is equal to a square is equal to b square is equal to c square. That we already have a condition, right? When a b c are equal, so this is again satisfying the same condition, so this is true. So I hope this is clear. Hi guys, so let's see the question number 3 of RMO KV 2025. So in this we have given a convex pentagon ABCDE such that AB is equal to AE and CB is equal to CD, and angle AED is 90, and angle that CD is also 90, and we have angle bisectors of EAB and DCB also, which intersect at I, and let M be the midpoint of AC. So this is M of AC. Prove that MIC angle is equal to angle AIB. So MIC angle is equal to AIB. So if you uh, remember about this thing, we call it as a median, right? So basically that we want to prove that angle MIC is equal to AIB. So we can say we want to prove that this IB is a median of triangle AIC, because this is a property of a median, that the angle made by the median with the one side is equal to the angle made by the median with the other side, right? So we try to prove that IB is a median. Okay, so this is a one thing. So if we prove that, then we are done. So for that, let's say this point is P. Okay, now we can uh, remove this angle for now, because if we somehow prove that P is a median, then we are done. Because if P is a median, then this angle is equal to this one. Okay, so let's see how to prove that this is a median. So before moving to that, how it is median, so we will first see that what we can get from the given things. Like we have given it is a angle bisector, it is an angle bisector, right? And this AE and AB are equal. So if I draw EB, can I say it is a perpendicular bisector of EB? Can I say that AI will be a perpendicular bisector of AB? EB, sorry, because it is an isosceles triangle. AEB is an isosceles triangle, so we can say that it is a perpendicular bisector of EB. So if I connect IE also, right, so we can say that IE is equal to IB. IE is equal to IB because I lies on a perpendicular bisector of EB, so IE is equal to IB, and in fact these two angles are equal also. This angle is equal to this. Or I can color it in some other color. Let's say this angle is equal to this. So let's call them alpha and alpha. Or so I hope this is clear. So it should be, these two angles should be equal, and also this IE is equal to IB. Similarly, if I join BD, so same thing we can do with the BD. If I connect BD, then again because BC is equal to CD and it is a angle bisector CI, so IC is a perpendicular bisector of BD. So if I join ID also, then I can say IB is equal to ID also. IB is equal to ID also, and this IC bisect the angle BID also. Yes or no? This bisect the angle BID also. So I can say this angle, these two angles are equal. So let's call them beta and beta. Okay. Now we can see one more thing, that BED lies on a circle with a center I. Yes sir. We can say that BED lies on a circle with a center I, because IE is equal to ID is equal to IB. Okay, so that is also we get from here. Now we want to prove that IP is a semimedian. Okay, and for that we have to prove that if we somehow find out that by PC AP by PC is equal to IA square by IC square, then I can say that IP is a semimedian, because this is the property, or we can say the vice versa of a semimedian, that if this ratio is IA square by IC square, then we can say that it is a semimedian. Okay, so now, so that is a, we want to prove IA square by IC square. So now let's try to see that we got angle alpha beta, and these are alpha beta, and let's try to figure out the other angles using them. So like if I say this angle is beta and beta, that is 2 beta, right? It is made by the arc BD on the center. So BID is the angle made by the arc BD on the center, which is 2 beta. So on the circumference it should be beta only, right? On the circumference it should be beta only. So can I say that angle BED is beta? Angle BED is beta because it is half of BID. So if this is beta, then this is 90 minus beta. If this angle is 90 minus beta, then this is also 90 minus beta, because it is an isosceles triangle. And these two angles are also equal, so we can say these are 2 beta total angles, so it is beta and beta. So we got these angles beta beta. In a similar way, we will find out that these two angles are alpha alpha, and this angle is 90 minus alpha. So we got a lot of angles here, that alpha means by angle chasing we can able to find out all these angles. Okay, so we want to prove IA square by IC square. Okay, so what else we have now? We have alpha angle, beta angle. This is 90 minus beta. So this is 90, and okay. So if we see the triangle IAB, if we see the triangle IAB and IBC, can I say they are similar? IAB and IBC are similar because they have angles alpha, beta, and alpha 9 means if two angles are equal, then we can say they are similar, right? IAB is similar to, so it is similar to A angle is beta, so this is I, and I angle is alpha, so it is C, so CIB, right? So this is they are similar. Now to find out AP by PC, as we want to find out AP by PC, so to get that, can we try to use this IAB similar to CIB? So from this we can, okay, so how to means there is one more thing that we can see, that as we have this angle is 90 minus beta, right? And if you see this angle you can find out it is equal to this angle, and at the center this angle is 2 alpha. EIB is 2 alpha, so this angle is 90 minus alpha, and similarly this angle becomes 90 minus beta. So I can say that BP is an angle bisector, because if you see angle ABP is equal to angle CBP, angle ABP is equal to angle CBP is 180 minus alpha minus beta. So these two angles are equal, so BP is an angle bisector. So AP by PC is equal to AB by BC. So as these two triangles are similar, so I will try to make AB by BC in terms of IA square by IC square. AP by PC I will try to convert it to IA square by IC square. So for that, like if I try to first find out AB, so I can say AB by IB is equal to IA by CI is equal to IB by BC. Okay, so to get AB we can use this. So AB will be equal to IA into IB by IC, and the second point from here we can write BC, which is IB into IC by IA. So if I put here it is IB, IC and IA. So you will get IA square by IC square, that we want to prove, right? So we got AP by PC is equal to IA square by IC square. So we can say that this is a summedian, and so summedian makes an angle alpha with the IA. The same angle will be made by the median with IC, that we want to prove, right? So this is the we can done by saying that it is a summedian. And also as I use some angle chasing to prove that this is the angle bisector, right? Here I try to prove that BI is an angle bisector somewhere. So basically that also we can uh, eliminate that step by saying that as we got the angles alpha and beta in triangle AIB, you already know the angle alpha beta. So the other angle you can easily get 180 minus alpha minus beta. So same you can say from here. So that angle bisector we can easily identify. Okay. So that is also we can reduce some steps. So ultimately I think this is clear. So this is how we can use a median this. So that's all for this question, guys. Okay, guys. Hi guys, so let's see the question number 4 of RMO KV 2025. So this is based on combinatorics. So in this we have given a frog which is initially at 0, 0, okay, and then it reaches n, 2. Let's say this is n, 2. So where n is greater than equal to 1, using the following moves in order several times. So we have a 3 moves R, U and D. So R move basically shift the frog 1 unit to the right, right? And 0, 1 move shift the frog to vertically 1 unit, and the D moves shift the frog 1 unit right and 1 unit up, right? So it reaches at this point. So we have to find out the number of ways, in how many ways can frog go from 0, 0 to n, 2 using the above steps subjected to the condition that the steps of the type UU and DD are forbidden. Means they cannot be consecutive steps UU and DD. Okay, so for example, for n is equal to 3, this is correct. These are admissible paths, but these are not because we have a 2D and 2U together. Okay, so but there is no restriction on R. Okay, so from 0 comma 0 we have to reach to n comma 2. Okay, so first we can observe one thing, that we have to go up by 2 units only, right? We have to move up only by 2 units, so that we can achieve either by using 2 U steps or 2 D steps. So possibility to go up by 2 units, either we have to use 2 U steps, or we can do this by 2 D steps, or U and D step, 1 U and 1 D step. And okay, so if we consider this case first, if we are using 2 U steps, we have to move how many steps to the right? We need n steps to go right, to reach n, or to move n units in the right direction, we need n right steps. So our path is a combination of R and 2U. How many R's we need? N R's we need, and 2U we need, right? And basically the arrangement of them gives us a different uh, ways to reach from 0 comma 0 to n comma 2, right? So number of ways in which we can arrange them, that will be the number of path from, or number of ways to go from 0 comma 0 to n comma 2. So that we can do by n plus 2 factorial, by n factorial and 2 factorial. Now we have to subtract some cases from here. So as we have a restriction that U cannot come together, so we have to subtract the case where the two U's are together. So now we will find the number of arrangements with NR and these two U as together. So how many arrangements are then? It is n plus 1 factorial by n factorial, that is n plus 1. So we subtract this number from this. So that is the number of ways when we are using 2U, right? And if we go for a U and D, the second case, if we consider, so this is a case number 1 when we are using only 2U, and the second case when we are using that 2D. Okay, so in 2D basically we are going 1 unit right and 1 unit up, right? So if we are using 2D, then we already covered 2 steps to the right and 2 up steps, right? So as total steps we need n, so total right we have to go is n, so it is n minus 2 rights we need. How many R steps we need now? N minus 2 R's and 2 D's, right? So using the same thing in this part, we will see that it is n factorial, because total will be n minus 2 plus 2, total numbers are n factorial, by n minus 2 factorial and 2 factorial. And also we have to subtract the case when 2 D's are together. We have to subtract the case when 2 D's are together. So those 2 D's together will give us the n minus 1 factorial by n minus 2 factorial. Okay, so that is the case when we have a 2 D's together that we subtract. So this is the case when we have when we are using 2D. Then we have a third one, is when we are using 1U and 1D. In fact, there is no restriction on that because U and D can come together. So in this case, 1U and 1D tells us that 2 steps up is done, and 1D is also cover 1 unit to the right when we are using 1D step. So how many R steps we need? N minus 1 R steps, 1U and 1D. So how many arrangements we can do? N plus 1 factorial by n minus 1 factorial, right? So these are the number of ways we can get in this case. So now if we add all the three, this one and then this one and this one, that will be our final answer. So if you simplify that and add them, you will get the answer 2n square plus 1. Okay, if you simplify them, you will get the answer 2n square plus 1. That should be the answer of this question. Hi guys, so this is the question number 5 of RMO 2025. So in this question we have given angle BAC is 60 degree and AB less than BC less than AC. So accordingly I draw AB, BC and AC, and M and N are the midpoint of AB and AC. So you can see in a diagram M and N, and then we have a BE and CF are the perpendiculars, right? BE is perpendicular to AC and CF is perpendicular to AB. Okay, so we have these are the perpendiculars and or altitudes, and then we have X be the image of M under reflection in the midpoint of BF. So if we say the midpoint of BF is this, then we reflect M about this point, right? And we get a point X. If we reflect this M about a midpoint of BF, its image is X. Similarly, if we reflect N about a midpoint of that is EC, so let's say this is the midpoint of EC, and if we reflect N about this point, is the image is Y. So we have to prove that XY bisect BC. So if I say they are intersecting at O, so we have to prove that BO is equal to OC. Okay, so this is the question part. Now let's try to figure out few points about the right angles, right, and about the midpoints. First thing, that we have to reflect M about the this point, right? So this is a midpoint of BF, or I can say it is we reflect M about the perpendicular bisector of BF. Yes or no? If we are reflecting M about this point, right, that means we are reflecting about the perpendicular bisector at this point. Similarly, this another point we can say that if we are reflecting N about the midpoint of EC, that is again we can say we are reflecting about the perpendicular bisector of EC, right? If we draw the perpendicular bisector, so then we take a mirror image of N about this perpendicular bisector, that is Y, right? So that is the meaning of a reflection in the midpoint of BF. So I hope this is clear. So the reflection about a midpoint is basically the reflection about the perpendicular bisector at the midpoint, right? Because only then it is if I say this point is P, then PM is equal to PX. That is we are saying, right? So we are moving along this line, so that is we can say we are reflecting about the perpendicular bisector of BF. Now this is the one thing that we can say. The second point is we have a altitudes, so we can draw a circle also, right? We can say that E and this point is F lies on a circle. I hope all of you know that BCEF is lies on a circle because they have an angle 90 degree. So BCEF lie is a cyclic quadrilateral and BC is a diameter. Yes or no? So we can say BCEF lies on a circle with the BC is the diameter, because F and E angle are 90 made by the BC. So if they lies on a circle, and we know that that perpendicular bisectors also related to the center. Like if you see CE, this if I draw this perpendicular bisector, can I say it should passes through the center? Means right now I'm assuming that if O is a midpoint, means we are just trying to construct a solution that as we want to prove that O is a midpoint, so I'm considering O as a midpoint, try to figure out that what we have here, that if I draw the perpendicular bisector of EC, that will passes through the center, right, of the circle. Similarly, BF is also the side of a or a chord of this circle. If you draw the perpendicular bisector, it also passes through the center, right? So let's see a more neat diagram. So this is the diagram we will get. So here I draw the perpendicular bisectors of BF and that EC, and let's call them a points P and Q, right? So we know that perpendicular bisector of a chord passes through the center. So we got they are intersecting at a point O. Okay, and we are reflecting M about P, and we are getting a point X. So can we say that if I join MO, MO is equal to OX, MO is equal to OX, right? Because it is a perpendicular bisector. OP is a perpendicular bisector, right? And we can say that MP is equal to PX also. So OM is equal to OX also, right? So similarly we can say ON is equal to OY. ON is equal to OY. So I will try to prove it in a way that I will say that, means I will try to prove that if I connect XO and YO, right? I connect X to O, and here I am assuming O is a midpoint. O is midpoint of BC, and I'm connecting XO and YO. If I somehow prove that, X, O, Y are collinear, then we are done, right? Because we want to prove that the XY line passes through the midpoint. So if I assuming O is a midpoint of BC and connect XO and YO, and then prove that XO, Y are collinear, then we say that we proved that thing, right? Now to prove that they are collinear, I will try to prove these two angles are equal. I will try to prove that BOX angle is equal to COY angle. That we try to prove, because if they are equal, then we can say that by that vertically opposite angles, the line should be sorry, it should be a straight line, right? If BOX is equal to COY, because BC is a straight line, that we definitely know, and if OX and OY make same angle, so we can say that it is a straight line. Now to find out these angles, again let's see that again we use a perpendicular bisector thing here. So as we already see that BOM is equal to OX, right? And OP is a perpendicular bisector of BF also. So can we say that OF is equal to OB also, or even this angle is equal to this, right? And this angle is equal to this one, right? Angle MOP is equal to angle POX, and also angle FOP is equal to POB. means that angle BOX will be equal to the angle MOF. So MOF angle MOF is equal to angle MOB minus angle FOB. So MOB angle, I think we can easily find out that, because M and O are the midpoints, as M and O are the midpoints, so MO is parallel to AC, or MOB angle is same as angle C. And FOB angle is twice of angle FCB. FOB angle is twice of FCB. So FCB is FOB angle is twice of FCB. Yeah. So what is FCB angle? FCB is 90 minus B, right? Because this is 90. So FCB is 90 minus B. So what we will get? Minus 180 plus 2B. So this is, we can get B plus C is 180 minus A. So 180 minus A minus 180 plus B. So that is 180 cancelled out. It is B minus A. With the same thing, we can also find out the angle, that this angle is equal to this one. So which is nothing but A minus C. So this angle FON is A minus C. Oh, sorry, EON is A minus C. So if we somehow prove that BA is equal to A minus C, B minus A is equal to A minus C, then we are done. And for that we can use that A angle is 60 degree. If A angle is 60 degree, right, then B plus C is 120. So we are saying that B minus 60 is equal to 60 minus C. I think that is perfectly fine, right? Because if B plus C is 120, then B minus 60 is equal to 60 minus C. That is perfectly fine, isn't it? So with that, we can say that it is a straight line, because we proved that angle EON, which is basically equal to the angle COY. So COY angle is equal to BOX angle. So we can say that it is a straight line, or XY passes through O. Thank you guys. Hi guys, so let's see the question number 6 of RMO 2025 kV. So in this question we have given that we have a sequence A0, A1 up to so on. A0 is 49 and AN is related to AN minus 1 in this form. For n greater than equal to 1, show that sum of digits of AN square is n square plus n plus 7 for all n greater than equal to 0, where Sm denotes the sum of digits in the base 10 representation of a non-negative integer m. So here Sm represents sum of digits. So we have given this is An. Okay. Now let's try to figure out first few values of A0. Like A0 is given, that is A0 is 49. If we go for A1, A1 is 10 power 2 into 49 minus 1, which is 4900 minus 1, which is 4989. Sorry, 4899, right? If we go for A2, it is A1 into 10 power 4 minus 1, which is 4899 4 zeros minus 1, that will be 489849s. So if we observe one thing, that the number of digits, like in A naught we have a 2 digits, in case of A1 we have a 4 digits, in A2 we have a 8 digits. So can I say that A0 have a 2 power 1 digits, A1 has a 2 power 2 digits, and A2 have a 2 power 3 number of digits. So basically AN has how many digits? 2 power n, n plus 1, sorry. AN has 2 power n plus 1 digits. And also you can see there is a repetition of a pattern is there, like 4 8. First we have 4 9, then 4 8 9 9, then 4 8 9 8, then 4 nines, right? So these are the few observations that we can see, that digit number of digits and the numbers are, we can see that we can easily form that number, right? So this is about A0 A1 AN. Now we have to, we do not have to find out sum of digit of AN, we have to find out square of that, right? So let's first try to figure out what is AN square. So AN square will be equal to A minus B square, we can apply, that is 10 power 2 power n AN minus 1 minus 1 square, that is A square plus B square minus 2AB. So it will become 10 power 2 power n plus 1 AN minus 1 square minus 2, or we can say 20 times, not 20, sorry, 2 into 2 into 10 power 2 power n AN minus 1 plus 1, right? So that is our AN square. Now sum of, as we can see, AN square is in terms of AN minus 1 square. So we can try to use a induction also, means we start, means we can say that as A0 we can say it is true, then as A R we can say it is, we assume it is true, and then prove for A sum of digit of A square R plus 1, that we can do. Okay, but the problem is here that we have a AN minus 1 also, and there is a minus sign. Okay, let's as we have to find out the sum of digits, so let's try to convert it into a decimal form, like AN into 10 power n, right, and something. So we need a all terms in a plus sign, right, with a plus sign. So first we try to eliminate this subtraction part. So for that, what I will do, I will, as we have a AN minus 1 square into 10 power 2n plus 1, so I'm picking 1, 10 power 2n plus 1, to make, to add in that, to make it a positive number. So I just take 1 into 10 power 2n plus 1 from this number and combine with this number to make it a positive number. So let's see, will it be positive with this? If we see, this one is fine. If we take 10 power 2 power n common, it is 10 power 2 power n minus 2 times an minus 1 plus 1, right? So can we say the second term is positive term? Like this term, it is a, how many digit number? 10 power 2 power n. It is a 2 power n plus 1 digit number. And what about 2 times an minus 1? As we already see that an has a 2 power n plus 1 digits, and an minus 1 will have a 2 power n digits, right? An minus 1 has a 2 power n digits, and if I multiply it with the 2 also, if we multiply it with the 2 also, it still have a 2 power n digits only. You can check that from here, like a0 is 49, so 2 times of a0 is 98, which is again a 2 digit number. A1, if you multiply it with a 2, it will be again be a 4 digit number. This is multiplied with the 2, again will be a same digit number. So basically an minus 1 when multiplied with 2 will the number of digits will be remain same. So means this number has a how many digits? 2 power n digits. So can we say that when we subtract it from here, we have still have a positive number, because it has a 2 power n digits, and this is 2 power n plus 1 digits. So this number is bigger than this number. So this becomes a positive number. This number becomes a positive number, and also that will not uh, affect the digits of this number, because if you see after the subtraction also, when we subtract these two numbers, ultimately you will get 2 per n digit number only. It is the smallest 2 per n plus 1 digit number. If you subtract this number, you will get a 2 per n digit number, right? So 2 per n digit number multiply with this, so you have a 2 per n plus 1 digits, right? You will have 2 per n plus 1 digits, and you can see this in this term, it has a 2 per n plus 1 zeros after this. So means the digits that we get from here will not affect the digits in this number. So we can say that sum of digits of an square is equal to sum of digits of an minus 1 square plus sum of digits of 10 power 2 power n minus 2 an minus 1 and plus 1, because the last an minus 1 square minus 1, sorry, and plus 1, because why we are adding 1, because the unit digit will be 1 only. The expression that we get, the unit digit will be 1, because in the first two terms the last digit is 0, so 0 0 1, it is 1. So we can say sum is this. Now we want to prove that S a n square is n square plus n plus 7, and so for that we can use a induction. We can assume that it is true for S, means we can prove that it is true for S a 0 square, that for S a 0 square, like what should be a 0 square from this formula? It is 0 square plus 0 plus 7, so it is 7. And if we find out a 0 square, which is 49 square, which is 2401, and exactly the sum of digit is 7, right? So means we can say it is true for a0. Then we can assume for a n minus 1 square, it is true, that is n minus 1 square plus n minus 1 plus 7. So we will try to prove, or we have to prove a n square is n square plus n plus 7. Now in that part, we have to first figure out this value, because that we can perfectly put this value. We have to further figure out this value, that what should be the sum of digit of this number. So now we have, let's pick this part and let's call it a n, which is 10 power 2 power n minus 2 times a n minus 1. So we assume a n is this, right? So, and if we put the value of a n minus 1 here, in like from this relation, that will be 10 2 power n minus 1 a n minus 2 minus 1. So if we simplify that, it will be 10 2 power n minus 1 plus 2. So if I take 10 2 power n minus 1 common, it will be 10 2 power n minus 1 minus 2 a n minus 2 plus 2. So this is nothing but a n minus 1, right? Or I can say that sum of digits of a n, because this is 0 zeros into this number plus 2, sum of digits of a n minus 1 plus 2. So we can see SAN is a AP with a common difference 2. Having first term is, if we go for the first term, that is A1, which is 10 power 2 minus 2A0, that is 2. So SA1 is also 2, right? So SA1 is 2, so we can say that SAN is 2n. Now if we put these values here, now what is an minus 1 square? Okay, we have a minus 1 also. So I can also say one thing, that sum of digits of an minus 1 square minus 1 is same as sum of digits of an minus 1 square minus 1. That I can say because I know that the unit digit of this number is not 0. Okay, it is a non-zero number, and if I the sum of digit of this number is same as this number. Like if I say I have a number 6 7, so either you find out a sum of digit of 6 7 and subtract 1, or else you subtract 1 first and find out the sum of digit, that will be same, right? So why we are saying that its the unit digit is not 0, because you can see the, as we already see, a1 a2 a3 and so on, so they are ending with a 9, right? So that is the reason that it cannot be a 0 number, because if it is 0 then there will be a problem, like 20, and if I subtract 1, that becomes, it is 19. So in that case sum of digits vary, but in our case it is not like that, it is not 0. Okay, so we can say this also. Now if I do all the things in this, so what I will get, n minus 1 square plus n minus 1 plus 7 plus 2n, and this minus 1 will cancel out with this plus 1. So if we simplify, this is n square plus n plus 7.